Hello friends, MoNaCo here, our first homework lecture note in our physical behavior matter unit. We're going to be talking about heat, temperature, kinetic, and potential energy today. We're also going to be major focusing on converting Celsius and Kelvin degrees of temperature. There's an equation on table T that we'll be using for that. So we've learned about potential and kinetic energy before, but they're not really temperature and heat. Aren't they the same thing? I mean, we kind of use them interchangeably so far. We're really going to get into the difference of those today because kinetic energy is heat and temperature is a measure of heat, so therefore temperature is a measure of kinetic energy, and we'll really get into that once we see our notes today. So energy and temperature. Energy is a capacity to do work. So we use energy to do things like light our lights, make reactions go. Kinetic energy is the motion or movement associated with temperature change. So it's the atoms and particles of a sample of matter moving around. Potential energy, phase energy, is like the position of stationary or stored energy. It's associated with phase change only, but not temperature change. So kinetic energy is the motion of particles, call it Brownian motion sometimes. Potential energy is the position and location of particles stored in a phase, solid, liquid, or gas. They are different. So temperature, being the average kinetic energy of a substance's particle, delta, that triangle means change in temperature, does not depend on the sample size. So you could be 1,000,000 degrees Celsius, Fahrenheit, or Kelvin, regardless of how large a sample is. But heat, on the other hand, is a quantity of energy. It can't be directly measured, but can only be measured as it is transferred from one object to another. And hot always goes from hot things to cold things. Heat always moves from hot to cold. It does depend on the sample size. So if you think about it, the more heat energy a sample has is related to how big that sample is. We're measuring heat in joules or kilojoules, or sometimes calories. And those are the same type of calories. They're related to food calories, but they're not exactly the same size. Okay, so again, temperature is a measurement of average kinetic energy, while heat is a measurement of how energy is transferred from one hot thing to a cold thing, and it's measured in different units. Temperature is Celsius, Fahrenheit, or Kelvin, right here. And heat is in joules, kilojoules, or sometimes calories, CAL. All right, so although there's a direct relationship between temperature and heat, they're not the same thing. Heat, as we mentioned, always goes from hot to cold. It's the natural order of things, hot to cold. Why? Because the universe says so. Higher energy to lower energy. The universe always wants to go lower potential energy and kinetic energy. It just wants to chill out. So energy flows from hot to cold in order to make that happen. When you say you feel cold, you don't really feel cold. You're just feeling heat leaving. It's kind of weird, but you got to start thinking about heat in that manner. Temperature is just a measure of average kinetic energy, and we have different scales that we'll be using to measure temperature. They're related, but they're not the same thing. There are 3 common temperature scales. Fahrenheit. We do not use this in chemistry class. We use Celsius and Kelvin exclusively. Celsius and Kelvin degrees are the same size. They're the same size degree, but they start at different spots. Okay? We use these 2 scales. Kelvin starts at what we call absolute zero, where no particles are moving, where Celsius starts at 0 Celsius, where ice is frozen. Okay, so thermometer scales are calibrated by fixed positions. In the freezing melting point of water, we got 0 Celsius, is also known as 273 K. The boiling point is 100. We call that an arbitrary type scale. The Kelvin scale are directly related to the motion of atoms, and we call that an absolute scale. I wrote this up above in brackets, but this is a very important thing to know. A change of 1 degree Celsius is the same as a change of 1 degree Kelvin. They're the same size degrees, but they start at different spots, as this picture illustrates. Absolute zero is negative 273 Celsius. I'm sorry, absolutely Kelvin 0 is negative 273 Celsius, and we don't even use Fahrenheit. We don't even care about it. We only care about Celsius and Kelvin. Moving on. How do we convert between the 2? We are going to use table T, conversion calculation. Because they're set off by 273 degrees, we can use this very simple calculation. The first one that I'll be doing with you is number 1. What Kelvin temperature is equivalent to 35 degrees Celsius? So we will use this variation of the equation, which you are receiving off of table T. So 35 degrees Celsius equals Kelvin degrees minus 273. Well, if I add 273 to both sides using my algebra skills, I will be solving for Kelvin as my answer. I want to see that when you do that for your homework check. Question 2 is very similar to the first one, so use the same type of equation. Now, question 3, which we'll be doing with you, is a little bit different because you have to rearrange the formula. So we're starting when the temperature is 300 K. What's the temperature in degrees Celsius? You got to rearrange the formula. So our formula was rearranged into this. Kelvin equals degrees Celsius plus 273. So I start 300 equals, let's check our equation, always check, Celsius plus 273. Now I use my superpowers of algebra to subtract 273 from both sides. And our degrees Celsius are equal to your answer. You see that for your calculation. Now here's the trick questions you're always going to see. Sample is heated and rises in temperature by 12 degrees. What is this temperature difference in Kelvin? You have to go back to your notes and understand that 1 Kelvin degree equals 1 Celsius degree. So when we have a change in 12 Celsius, that's also delta T, means change, equals 12 degrees Kelvin, or 12 Kelvin degrees. Sometimes you don't see the little degree symbol when you see Kelvin used. Sometimes it's just a K. Okay, 12K. This practice chart, back and forth, Celsius, Kelvin, Kelvin to Celsius. This is how you get your credit for doing homework here, because we don't have any practice pack pages. So this is all on you. You do, using the equation from table T. These questions, for you to think about, ponder, are related to heat and temperature. So most directly related to the Venn diagram that we did a little bit before. So make sure that you're answering these questions, reading for comprehension, and focusing on attention to detail so that you can figure out how heat and temperature are related. It's all in the notes for you to review. So go back and review those as you answer these questions. Now, at this point of the game, you should be able to discuss the difference between heat and energy and be able to convert from Celsius to Kelvin's degrees. There are 2 pages in our practice packet for you to complete on this material. And that is it. Thanks a lot. Have a good day.